Determine if f of x is even, odd, or neither. Okay, the governing equation for oddness is I plug in negative x and I get negative f of x back. And for oddness, we are thinking about functions like sine of x, x cubed, x to the fifth.
And tangent as well.
X to the, yes, tangent, x to the 11th. Tangent is actually, well, I'll get to tangent in a minute. I was going to use that as an example. Let me erase this messy f there. Okay, this is oddness. Evenness is f of negative x gives us f of x back. And the models there are cosine x. Any constant, like 17, would be even. And x squared, x to the 2012, etc. Okay? Already, from what I've given you enough clues to know that this guy right here is neither, because we've got a mixture of oddness and evenness, and they're added. Okay? But let's actually test it carefully, right? So let's look at f of negative x. It'll be negative 4x to the 7th, positive 32x to the 5th. I'm skipping the details because we know that negative x to the 5th turns out to be negative x to the 5th. Negative x to the 7th
is negative x to the 7th.
Etc. Right? And of course, if the exponents were even, then we wouldn't, the negatives would go away. All right. So negative 4x to the 7th plus 32x to the 5th minus 69x cubed. And we've got a streak of negative f of x parts, right? So each of these pieces is hinting at a negative f of x. But to spoil the run, negative 7 stays the same. So this guy right here is straightforward f of x. So this is a big fat neither. Okay. Next one. Okay. Here, again, let's plug it in. But before I do that, the cube root of negative 1 is negative 1.
Yes.
Right? So the cube root of negative x
is negative x.
Is the cube root of negative 1 times the cube root
of x. Okay.
Of x, right? Which is negative 1 times cube root of x. Again, the oddness of the number 3 should hint that this guy ought to turn out odd.
Yes.
Right? Otherwise, our name doesn't make any sense. But, so I'm just prepping for what to do here. Now, f of negative x is going to be...
sine of negative x.
Right. I'm going to skip straight to minus sine of x.
Yeah.
Because we're expecting that to be odd. It was one of our basic examples. Minus 7x to the 11 plus 8x to the 7 minus cube root of x. Again, skipping the details because all those integers are odd, which, through some careful pulling out of negatives, I can factor a negative 1 out of the numerator and out of the denominator, and I'll get sine of x, 7x to the 11 minus, minus 8x to the 7 plus cube root of x which equals f of x. Okay? So we've just verified that it's even.
Yeah.
But notice that what we really did in this example was we had an even function. Oh, I'm sorry, we had an odd function over an odd function. So if I have like g of x over h of x, and they're both odd,
Then it becomes even.
right, because I'll do g of negative x, so f of negative x equals, sorry, I'm getting ahead of myself, getting a little sloppy. F of negative x equals g of negative x over h of negative x equals negative g of x. Here I'm using the oddness of both of them,
Yeah.
right? Same thing happens. And you mentioned tangent before. So tangent of x is sine of x over cosine of x. This is an odd function over an even function. The same pattern is going to play out, except for when we get to this stage, there'll be no canceling. We'll have a minus and a plus. Okay? So what I'll get is tangent of negative x is sine over cosine negative sine x over regular cosine x, which is, of course, negative tangent.
Yes.
And all I really did, there's nothing special about the letters sine or cosine. All I really did was use oddness
Yeah.
of the numerator and evenness of the denominator. Right? Okay. But if you're just careful about plugging in the negative x and seeing what you get, then that's that with even and odd.